Continuing the law of cosines recap, got interrupted and didn't have the presence of mind to pause it correctly. We're in this situation where C is obtuse, and so this doesn't seem like exactly right, because the cosine of C, that's going to be negative. And so what and the other reason is it's not even the angle inside the triangle. So it looks like we might have to take like a 180 minus C to get this angle. But it turns out it works out beautifully, because if I look at the cosine of 180 degrees minus C, if I look at like the unit circle, what that does is it takes an angle and it flips it across. We determined that a pi minus or 180 minus flips it across the unit circle, flips it across the y-axis. So that gives you minus of cosine C. So this is what I really should be taking instead of C, but it's easier to write just cosine minus cosine C. That's going to make it a positive number. So cosine C is going to be negative because it's an obtuse angle. That's where one of the places where cosine is negative. But the minus then turns it back into a positive, and it gives us the right x. Okay. The h isn't going to be a problem at all. It's still totally fine, because the sine of this angle is the same as the sine of this angle. So when you flip something across in this way, sine of 180 minus C, that's equal to just sine C. So the h is going to be no problem. And now let's see, what about the x? So now x is minus b cosine C. That does seem to be different. It seems to spell trouble for having one formula for both cases. But let's see what happens. Now the y, which we're going to use Pythagoras on, the h is going to have exactly the same formula. If we can get the same formula for the y, will be great, because then we just use Pythagoras and we'll get exactly the same thing. And look what happens with the y. Y is now a plus this quantity, or it's a minus b cosine C. If you compare that with the acute case in the other video, that's exactly the same formula. It isn't different at all. So the fact that we had to do a little bit of a different comparison of ya and x exactly cancels out the fact that we had to put a minus sign here, and it all works out. The punchline is there is only one law of cosines. It does not vary on cases, and it's still just c squared is a squared plus b squared minus 2ab cosine C. The rest of the derivation, once you've figured out your y and your h, is just Pythagoras and some algebra and a trig identity. None of that's different, so it does work out. So we could, it's reasonable to worry that when you start deriving this for yourself, that maybe the acute and the obtuse might be different. The wonderful thing is they're not different. That's the universal law of cosines. And we're actually going to look some more about how when this is positive, negative, or 0, it gives us exactly the right kind of behavior. But that's a good place to stop for now.